Hello students and welcome to the first module of our new chapter 3D lines. This module says vector equation of line with a point and parallel vector. So here we are going to see some equations of line in space, that is 3D line. The first one is vector equation. Let us start. Now this is a first theorem where we try to find vector equation of line. Let us see the statement of the theorem, students. The statement says the vector equation of line passing through a point A, that is A bar, and parallel to vector B bar is R bar is equal to A bar plus TB bar, where T is a scalar. Okay, let us start. Let's consider a line L in 3D space. So 3D space means X, Y, Z axis and three planes. We know, yeah? Let us say there is a line L. Now, from the theorem, we have given data as A is a given point on the line and B bar is a parallel vector. Alright students, so in this diagram, we may select a line which passes through a point A. Let us say this is a point A, having position vector A bar, and there is a parallel vector B bar. Okay, now once we have this data, to find equation of line, let's consider a variable point on the line. So let us say P R bar be a variable point on this line. So there comes P having position vector R bar. Okay students, now once we have this diagram ready, from this diagram we can say let P R bar be a variable point on the line. Now AP bar is parallel to B bar. Now vector AP bar is parallel to B bar. That means when two vectors are parallel, we can write one vector as scalar multiple, that is A bar is TB bar. So in our case, we can write down here AP bar is equal to T times B bar. AP bar, students, is R bar minus A bar, which is T times B bar. And on simplification, we get R bar is equal to A bar plus TB bar, where T is a scalar. Okay students, now this expression is a vector equation of line or parametric equation of line. Here let us check different parts of this equation, students. Now in this equation we have R bar, which is variable point, A bar which is given point, and B bar which is parallel vector. Alright students, let us proceed, and we can say here we will study two more forms of equation of line. So the line is same, let us prepare another form of the equation of line. Alright, now let's consider a line passing through point A and parallel to vector B bar. That is our same scenario. Now here we can say P R bar be a variable point and AP bar is parallel to B bar. But if vectors are parallel, from vector geometry we say AP bar cross P bar is 0. This becomes R bar minus A bar cross P bar is 0. That means this equation does not contain parameter, which is non-parametric equation, which can be written as R bar cross B bar is equal to A bar cross B bar. Alright students, now let us study the third type, which is another form of equation of line. Let variable point be X, Y, Z. And therefore let R bar be Xi cap plus Yj cap plus Zk cap. Given point be X1, Y1, Z1, which gives A bar. Now students, we know ABC be the direction ratios of parallel vector. So B bar is Ai cap plus Bj cap plus Ck cap. Now DRS of AP bar are X minus X1, Y minus Y1 and Z minus Z1. Alright, direction ratios of B bar vector are A, B, C. As AP bar is parallel to B bar, we can write down A1 upon A is B1 upon B is C1 upon C, which gives us this equation, which is called as Cartesian form of equation of 3D line. Alright students, now here the variable point on the line is X, Y, Z. Right, now given point is X1, Y1, Z1. Okay students, direction ratios of parallel vector are A, B, C. Let us summarize everything we have studied so far, that is different equations. Here students, for a line passing through a point and parallel to a vector, we have vector equation, that is R bar is equal to A bar plus TB bar. Then non-parametric form, which is R bar cross B bar is equal to A bar cross B bar. And the third one, Cartesian form, which is X minus X1 upon A equal to Y minus Y1 upon B equal to Z minus Z1 upon C. Now in all these forms, given point is A and parallel vector is B bar. Okay students, thank you.